Perform and complete a full hypothesis test for the mean with population standard deviation known. We're going to do this with the p-value approach. So first, let's read our question. George, an economist, is studying income data and would like to test the claim that the salary for recent college graduates in a metropolitan city is less than $50,000 on average. Remember that 50, we're going to need it. He decides to complete a hypothesis test at a 10% significant level. He samples 36 recent college graduates in the metropolitan city and determines the sample salary to be $47,000. Assume the standard deviation is sigma equals $7,000. Let's work through the test procedure and interpret the results of the hypothesis test. Just to refresh, those steps, we're going to identify the null hypothesis and the alternative hypothesis. We'll decide on the significance level, we'll compute the test statistic, we'll find the p-value, and using that information, we will then interpret the results of the hypothesis test. Let's jump in. First, to identify the null hypothesis and the alternative hypothesis, we know that George the economist is studying income data and tests that the salary is less than $50,000. Now remember that the null hypothesis is always the equality. So we know that h sub 0 is mu equals 50 because the null hypothesis is equality. Because our statement is less than 50, then our alternative hypothesis is going to be less than. That also means this is a left-tailed test, just for reference. Next, let's decide on the significance level. Now, he does tell us, George the economist, that we are going to complete the hypothesis test at a 10% significance level. That means alpha is 0.10. This is what we're comparing our p-value to, right? Because with the p-value approach, we compare our p-value compared to our significance level, and that's how we make our decision. Let's compute the test statistic. Now, there's a lot of pieces that we need. We need our samples of 36, the sample mean that we find of $47,000, and we have our standard deviation. Don't forget that 50 that we started with. So we know that our sample mean, x bar, is 47. The $50,000 that we started with, right? That's our hypothesized piece. So that gives us our mu of 50. We know our standard deviation is 7 and our sample size is 36. So once we have all of our values identified, and I highly recommend that you write these down, identify the different pieces that you're going to need, so when you plug them into your formula, our test statistic, when the population standard deviation is known, gives us a z score here. So we're going to take x bar minus mu sub 0 divided by sigma divided by the square root of n. So keep your formula handy. And again, I recommend you write the formula down first, then you can substitute your values in accordingly. Do the math, make sure you keep your numerator and denominator separate, use parentheses in your calculator, and you should end up with a test statistic of negative 2.57. Using that test statistic, the hypothesis test is a left-tailed test, so that means the p-value is going to be the area under the standard normal curve to the left of the test statistic of negative 2.57. So we're going to use the standard normal table. The area under the standard normal curve to the left of the test statistic of negative 2.57 is 0.005. And this is rounded to 3 decimal places. Now, when you're looking at the standard normal table, it's a z-score, right? So you can find negative 2.57. The table gives you area to the left, which is what we want, and we get 0.005. So thus, our p-value for this particular problem is 0.005. Now we can interpret the results. So if the p-value is 0.005, that is less than the level of significance, which is 0.1. So since the p-value is less than the level of significance, we reject the null hypothesis. So our statement, our interpretation, at the 10% significance level, the data provides strong evidence for George to conclude that the salary for recent college graduates in a metropolitan city is less than $50,000. We have strong evidence to conclude that this is true.